Hello, everyone, and welcome to our presentation about our dataset presentation. I am Mehmet Turhan Bilgin. I'm from the Computer Engineering Department, and I will introduce ourselves, the presentees of the dataset. Our dataset presentation will conclude of the problem definition, the summarization of our data, with a few graphs, with a few graphics, which we will use near the end, and we will conclude with a short ending statement. Health and insurance companies around the world have been looking into insuring as many people around the world as they can in order to provide medical and monetary safety for their customers and to ensure the vehicle market standards stay at their current standings or even improve across the years. The problem we're addressing is finding whether the customers of an insurance company, whether they would be previously insured or not insured, would be interested in or would be willing to buy an insurance based on their personal details the details of their current vehicles. The importance of this data is based upon many factors. For example, with the results of this data set, the insurance companies can figure out which customers to focus on so that they can maximize their sales, as well as making sure that their customers are safe and sound. Additionally, this dataset can be looked into further so that better price points and sales can be arranged in order to maximize the number of customers. And Duygu can tell you about where I found our dataset and more.
Hello everyone, I'm Duru. I'm studying chemical engineering. However, in this section, I will try to explain where we selected the dataset, the number of our sample, the sample of our numerical and categorical features, and what our target is. First of all, we found our dataset by searching on kaggle.com, and the name of the dataset we choose is Health Insurance Cross-Sell Prediction. The dataset does not seem to have any of mismatched or missing data. However, some of our features have missing descriptions. The numbers of all the valid data can be found at the Kaggle source page. Anyway, if we go to the content of the dataset, our selected data contain 127,037 tests and 381,109 trained data samples, total of 508,146 samples with 10 features. You can see on the right of the slide. We have 5 numerical and 5 categorical features. The target value of the data is response feature. As a footnote, the test data only includes customers who are not interested in buying insurance. As meta attribute, unique customers ID information given. Now Ege will explain our features.
Hello everyone, it's Ege Baran Ayhan from Automotive Engineering Department, and I would like to explain you our features. First, we have 3 basic information about the potential customer, ID, gender, and age. After that, the driving license comes, if the customer has the driving license or not. The region code for customers, region code that he or she lives in. The previously insured means if the customer is insured or not. The vehicle age is the age of the vehicle from customer. The annual premium means that the amount of money customer needs to pay for 1 year of premium experience. The policy sales channel is where the customer hear about us. It's the anonymized code, so we don't actually know what is the code refers to. The vintage means the number of days customer has been associated with the company. The response as our target value means that the customer is interested or not. So my friend Turhan will talk about these features and their correlations furthermore.
Hello, it's me again, I'm Turhan. First, I will go over some unuseful features that we have. Here we can see 2 graphs which include statistics which do not seem useful for our project. First graph signifies the vintage, how long a customer is affiliated with the insurance company, and the response rate by percentage. Looks like the vintage data does not have any major effect on the response rate, so we have decided to exclude it for now. On the right graph, though, we see the policy channel definitions, which are the number of ways an insurance company can contact the various customers it has. While this data is useful in its own right, it does not seem to explain which channel corresponds in what way of communication. It might be phone, might be mail, might be face-to-face communication, etc. So while we will most likely use this data by itself, drawing connections to other points of data will prove a hard task, so we might exclude this point of data. In this graph, the top one, we see some useful correlations between some data. The vehicle age data and the response rate of the insurance, for the top, for example. 0 signifies a rejection of interest, and 1 implies the customer having an interest. Here we see if the customer has had the car for less than a year, the response rate is reduced significantly, as you can see in the blue section. And for customers who have, direction section, sorry. And for the customers who have had their cars for between 1 and 2 years, the response rate seems to increase by about 25%. Additionally, if the customers who have had their car for more than 2 years seem to have more than double the positive response rate compared to their rejection rate, even though their number seems quite low. On the bottom graph, we see if the customers who have damaged their car in the past will be more interested in having an insurance, while undamaged car owners might have about a 57% rejection rate. The customers who have damaged their cars in the past will most likely be interested in an insurance, having over a 95% acceptance rate of the insurance. In this final graph, we can see the age of the customers overlaid with their response rate. As you can see, the customers who are between 30 and 60 years old seem to be in the optimal acceptance group, being the only age gap that seems more interested in having or renewing their insurance compared to other age group. Now my friend can tell you more about the orange data validations that we have done while working on this project.
Sorry, so our data set includes 3 CSV files, one for train, one for test, and one for sample submission. The train data set has 381,000, as we talked about, samples, and with target value. Meanwhile, test data set doesn't have a target value, so we need to predict these values and then check the results with sample submission, which includes the test results. So we firstly added our train data set and sample it with 30 to 70%. And we get the results with test and score, and more than 87% of train data set and more than 89% of test data set success. And we then added the test data set and using the KNN model to train our data sets and predict the test results. So we get more than 95% of success rates with this way.
Okay, hello everyone. I'm Emrecan Varyok from Automotive Engineering. I'll conclude our presentation quickly. We selected a data set about insurance, looked at the data set's properties, searched for the functional feature patterns, tested it with a simple kernel algorithm. Feature correlations we shared are the most obvious ones, of course. There might be much more patterns between features and that machine learning algorithm can catch for us. We may contact the dataset's author for the missing feature descriptions like region code and sales channel. But for now, we think that we have a dataset that looks good enough for a supervised learning classification. Thank you, everyone. We can answer any questions.
Okay, so let me ask you. First, thank you for the presentation. But I expect more than this. So what kind of techniques you have learned to analyze your data? Again, for example.
Okay, we have learned the prediction method.
No, I don't ask any methods. I ask what kind of data analysis methods you learn. So have you applied any binarization method? Have you heard this? Have you read this?
Yeah, yes, but we only needed to check just for an idea, because we don't. I don't think that we should add this to our presentation.
But you have the continuous data, right?
Yes.
So why don't you binarize them? For example, you can create the bins. Go to the feature, your features, show me your features again. Here, you see that there is the age feature, right?
Yes.
And you can put this age into bins. Why didn't you try it?
I guess we didn't think about it.
So there is nothing, you didn't mention about how to use the bins for continuous data sets, for the data features, right? Like any premium, I think it is also continuous, right?
Yes.
For this. And vehicle age, okay, maybe you don't need. And what's the
It's
other?
categorized actually.
And other thing. As for the, I don't know, any policy series, channel, vintage, response, previously insured. So you didn't provide these kind of informations as well. So for example, the binning to create these discrete classes. So one of these features is that, or the things that you can apply on features. And the other is the transformations. So have you think about any transformations on features?
Well, we only eliminated the vintage feature, and the others were actually they all needed for our calculations.
I didn't see any distribution graphs. Have you checked the distributions, collected data distributions? Are there any bias? For example, if these data are biased to older, elder people in, so you can think of that, maybe you decrease the number of some age groups in the data set.
And could you come to age graphic, please? Well, we actually showed the graph of the age discrimination, but
the blue and reds are
blues are
the insurance, right? Okay.
Blues are they are not interested in with our offer.
Emre Can?
We only use the basic visualization techniques, graphs,
Yeah, I
bars.
understand, but there is nothing related with the distribution of the feature values. For example, when we look at these age, for example, again, the age 50 or the between 50 and 60, how many samples you have in the data set? We don't see this. Am I right?
Yes, it's actually sum of red and blue correspondings of frequency.
Okay, it is okay. What I am saying that if you go to the features again, you need to provide you need to check the distribution of these feature values. Assume that in the collected data, if the age distribution is biased, for example, your samples from always the ages between 50 and 60 between. Then do you think that when you train a model on that data set, it will generalize this information to reflect on real life? For example, if a new customer at 30 years old arrives you, your model will predict the result correctly by using these data?
We hope so. It can be improved, of course. We will work much
because
harder on it.
data always, your model always see in your data, collected data, the older people are older than 50. So you can check these kind of anomalies in the data, bias in the data by looking at the distribution graphs of the features.
Teacher, can I tell something?
Yes, please.
We actually have more than 15 graphs. However, we didn't want to put too much graphs and make the presentation so long.
And then you need to mention that in your presentation, maybe put all of the 15 in one slide and say that we have checked all the distributions of the features and we understand that they are all biased. There is no problem in that. But maybe you would say that after checking these features, we have a problem in region code. these are all from the same region.
Yes, you're right. Yes, we could
So
have
you
done
need
that.
to report it. I don't want hundreds of graphs, but you need to report what you have done and what you found. So these are the
Yes,
basic
you're right.
things. I am expecting from that presentations information about your features, your findings, what to do with the, let me say, problematic features, what you are gonna do, how can you solve it. So how many missing data are there, Duygu?
We don't have missing data.
You don't have any missing data, right?
Yes.
Okay, so you need to check if you have some very low, very high data, the scale of the data. Now, can you tell me what is the scale of, I don't know here, vintage, for example? What's the range of the values in the vintage feature?
No, I can say this.
You cannot say. So you didn't provide the range. So if you see that, for example, in the vintage, if you check the range, maybe you see -7, for example. Then you will understand that -7 is not reasonable, right? In the vintage, a person cannot be working with you for -7 years, right? So checking this kind of information will help you to detect some errors in the data collection process. Do you understand what I'm saying?
Yes.
Yes.
Yeah. So you will say that, oh, in that sample, I need to move it, or because we don't know actually 7- is not correct, for example. We know that. So you need to check these ranges as well. If the range is very, very different, I mean the wide. So for example, between 100 and 1 million, then you need to transform it, right? Using some transformation methods. Because you know the linear models are very subject to scales of the features. They told this. So how can you handle this feature? And now you don't know in which features you have large ranges. You are not aware of that. So I think this preparation is not enough. Is not enough. So please go over the resources that I already shown you and check your data more. Okay, but this time your presentation is not good enough to reflect how much you spend your time on the data. So please work on, and in the orange, you have lots of widgets to analyze your data, but for just creating the graphs is not enough. You can create hundreds of graphs by yourself, but you will show me only 3 or 4 and saying that there are some problems, there is some anomalies. We need to fix this by using this method. Okay? And do you have any new features? Do you want to plan, Mehmet Turan? Do you want to plan, create new features?
Currently, the features at our disposal seem enough, so we do not have currently any plans for any new features.
I don't think so. I don't think so. If I were you, I would think of it. For example, let's say the ages, I put them in beans and create age beans. So I will group the people according to the ages as well. So because 32 and 33 will not behave differently, I believe, right? You show me that the 30s are behaving together, right? Go to that slide, age slide. And here you basically yourself, you are reporting that between 30 and 60 are behaving similar, right? So if you put these people into some beans, create a new feature and put the 10 decades for the ages, between 20 and 30, 30 and 40, 40, and put these 1 and zeros, okay? And then you can create 6 new features. Do you understand what I'm saying, Emmett?
Yes, we will keep that in mind in the future.
So then you're adding 6 features. For example, one feature is saying that if that user is between 30 and 40, 1 or 0. Another feature is if it's 40 and 50, 50 and 60, like that. So that you see that if you put these 10 years beans, and if you put after that, if you spend some time on it, you will see that you will get more good sampling method for the relation with the target value. And on that graph, we already see that.
Okay.
So basically, I guess that, I expect that after that graph, you would come up with new features. For example, only that we are talking only for the ages, and for the other features, you have to think about like that, what you can do with that feature. And go to the feature spec. Okay. Here, Emrecan, for example, maybe you can create new features by just using the existing features, right? Can you imagine anything?
Yeah, maybe ratios between features can come up with a new feature.
But there should be some logic coming from the business.
Yes, yes, of course.
For example, we can think of the regions over there, region code. In some regions, income are higher, average income are higher than the other regions, right?
Yes, yes, it's possible.
Possible. So maybe you can find some information about these regions and their income, and you can put this income, average income, into as a new feature. I don't know. I'm just guessing right now. I'm just trying to make up some examples. So you need to think about this. Did you think about this kind of things or expansions on the features?
Yeah.
I think not. Okay. So policy sales channel, for example, have you checked this annual premium? So you need to think of it, right? So for example, annual premium, if there is an inflation in the country, you need to normalize it, for example, right?
Yeah.
Yes.
Across the age, across the years. So what I am saying that there are more approaches to deal with the features and transform features into new features, or remove some features, or transform the values of features, and of course report the feature values, and you are missing a lot of them. Do you understand? Do you understand my point?
Yes, sir.
Yes.
Yes, sir.
Okay, please.
We will discuss it more.
Yes, please, for the next presentation, extend your discussions on this and present new findings as well for the next presentation. It is 2 or 3 weeks later.
Yes.
All right?
Okay.
All right, sir.
Okay.
Thank you, sir.
Thank you for the presentation.
Thank you for your feedback.
Let's continue with the next presentation.